Um, it's
Or
basically
you just
like
don't know? Whatever.
it's like all of them. It's 5 subjects, including calculus, that they're testing me on.
Got it. Okay. All right. So that was conics, and then we can get into that more in this later if you need to. Graphs and their properties. So that graphs and their properties would be probably related to, and again, I'm just kind of, this is kind of a general thing that they're asking me, but I'm just giving you an overview of all the things that you might have to do for these kind of questions. So graphs and their properties, I would suggest that that would be something relating to, like, if I show you a graph, can you tell me what it is? And can you tell me something about that graph? For instance, if I showed you this graph, can you tell me what kind of graph it is? And even tell me the equation of it?
I think so. It looks like probably x minus 2, or like
Good.
2, or like
Very
one
good.
half
So
x
it's
minus 2.
linear, right? It's linear,
Yeah.
right? And the slope looks like it's about 1, right? And the y-intercept looks like it's about -2. Good. I like it. So the equation will be y equals x minus 2. Good. Awesome. And what if I gave you a graph like this? What would this graph be? Can you tell me what the graph is and tell me something about the properties of it? What kind of graph is that?
Yeah, that's a parabola. Um, it looks like it just. Oh wait, you said the
So
properties?
it's, yeah, so is it a linear equation?
No.
What kind of equation is it?
It's a parabola, so it would have to have a squared x in there
Yeah.
as the highest power.
That's called a quadratic, right? It's a
Quadratic, sorry, yeah.
quadratic equation. Yep. Good. That's like, instead of linear, it's quadratic. So you can see that. Oh my gosh, what do I keep doing that for? You can see that this point right here is the vertex, right? So that, what's the property? Well, that would be the vertex, and that might be, I don't know, -3 comma +2, right? And it's going up. So, and it looks like it pretty a standard parabola. So it's probably y equals x plus 3 squared plus 2. Does it seem like it, what it might be? You see how I came up with that?
Yeah,
Because
yeah.
it's 3 to the left, 2 up, and it's going up, and it looks pretty standard. Now, what if I took the graph and I made it broader, and I made it flip so it went down? Now, what might that equation be?
You would increase the slope, and you would also put a negative sign in front of it.
Very good. So it'd be maybe be -2.
Yeah.
Actually, that's actually making it steeper. So it probably would be -1/2, because the
Oh,
slope is
yeah.
actually less, right?
Yeah, you're right. I
Right.
do
And
have
then
one.
but it would still be this, right?
Yes.
-3 squared plus 2. Good. Or plus 3. Good.
Oh, one question. Sorry. I do
Hmm.
have a problem. Like, I don't understand like how to decipher the difference between like where to put the negative for like a vertical versus horizontal reflection. Like I know like when it's reflected across the y-axis, the negative sign would be on the inside of the parentheses.
Hmm.
But a lot of
Yeah.
the time, whenever it's factored out, it's like different, and I don't
Yes. It kind
know.
of just depends. That yeah, you're right. It kind of just depends. So if you wanted to take, it depends on the kind of graph. If it's an even or odd function, it kind of depends on a couple different things. But like, if in general, if you make a function, if you put the negative on the inside like that, then what you did is you reflect f of whatever f of x was over the y-axis. So that would be since it reflects it over the y-axis, that would be a vertical reflection. For example, if x squared was your function, then plugging -x into it, does it really change it? What is -x
Um,
squared the same as?
uh,
It's just the same. It's just x squared,
well,
right? So what did it do? Well, this graph just looked like this, right? So if you
Yes.
put the negative on the inside, what did you really do? You just reflected it over itself, but does it look any different? If you reflected it over this vertical line, over the x-axis, does it look any different to
No.
reflect this? No. But if you did negative f of x, what would that look like if you did negative x squared? Now a negative is out front of that. It's not being squared, right? So now that graph would be going down like this. See what I'm saying?
Mm.
So that reflects over the x-axis, or it reflects it vertically. Reflecting it over the x-axis means it's reflecting it vertically. And that's why that negative is on the outside, it's reflecting it vertically. When the negative is on the inside, it's reflecting it horizontally over the y-axis. So you kind of have to be careful how you say that. If you say y-axis, you're probably thinking vertical, but actually reflection over the y-axis is a horizontal reflection. Reflection over the x-axis is a vertical reflection. Did that help? Did that kind of answer your question?
That makes more sense. Yeah. Thank you.
Yeah, it's a little tricky. Those are always tricky. Kind of have to think about it. So I hesitate just to give you a pat answer about what happens when it's negative on the inside outside. I just like to look at some examples and then think through the problems, because there's different ways they could ask those questions or even provide it in an equation form. And so you just have to think it through a little bit, like I just demonstrated. Okay.
Okay. Thank you.
Let's see what else. Graphs and their properties. We talked about that. Higher degree polynomials. So that would be, this probably has to do with like how many zeros are there, how many x-intercepts are there, maybe complex numbers is related to that a little bit. Like, how can you tell if there's a complex zero? Like, for instance, for this red graph right here, that's a quadratic, right? How many zeros are there? How many
I guess
that means
one.
how many x-intercepts?
Oh,
There's
zero.
none. There's none, right? Because it's opening up. There's an y-intercept, but there's no x-intercepts, right? So the solutions for this, if you're trying to solve it, excuse me, set it equal to zero, the solutions would be no real solutions, but there are complex solutions. And those are the ones that have an I in it, right? The square root of a -1. So that probably relates to that. And more specifically, if I have, do you remember doing like synthetic division and all that kind of stuff, like to try to find zeros? So for this problem, higher degree polynomials, they might give you an equation like 0 equals 3x cubed plus 4x squared minus 2x plus 1. And they will say find all solutions. Not all real solutions, all solutions, complex solutions including. So that graph might have 3 solutions. It might have 3 real numbers. It might have only 1 real solution and 2 complex solutions, but it will definitely have 3 solutions if you count multiple solutions, multiplicity, and if you count complex numbers, right? And so there's various ways to do that. One of the easiest ways to do that is to just take your graphing calculator and plug in your graphing calculator and see if you can find one of these solutions. Now, you might not be able to find it, but you can try. So plus 4, by the way, I just made this up, so I have no idea what the solutions are. They may not be nice numbers. 2x
that's fine.
plus 1. So if I look at the graph for this, how many real solutions are there for this problem? Can you tell?
Only one.
That's right. There's only 1 real solution. It's right there. And I can't even tell what that is because it's not a nice number. So I won't be able to tell you what the other solutions are for this, but the other two solutions are not real, they're complex. How I know that is because it doesn't ever cross the x-axis again. It only crosses it one time right there. And the 0, like I said, is not a pretty number. So the way you would find out what those solutions are is how would I find that solution? If it was a rational solution, if it was a rational number, then it would have to be of the form P over Q, where P is a factor of the constant and Q is a factor of the leading coefficient. So that kind of narrows it down. You know, it has to be 1/3, -1/3, 1, or -1. And you know, it wasn't any of those. So it's not irrational. It's not rational. It must be irrational, I believe. Is that what that would mean? And yeah, that's why I shouldn't make up problems, because I can't do that for you. But that's probably what higher degree polynomials has something to do with. And if this was like 5 instead of 3, there would be up to 5 solutions, real solutions, up exactly 5 solutions if you count complex solutions and multiple solutions of multiplicity more than 1. Remember doing that?
Oh, okay. Yeah, I do. Thank you.
Vaguely.
Yeah.
Word problems and modeling, that's just a lot. There's a lot to that. I can't even really get into that. That has to do with, like, you know, business type stuff where you're trying to solve systems of equations or linear programming types of problems, or maybe you've got financial problems like interest problems, right? Banking, remember compound interest and all that kind of stuff. But
Yeah,
way too many for me. Certainly can't make one up for that. Oh, look.
that's true. I did want to actually ask you one
correct?
thing about.
Mhm.
Oh, sorry. Can you hear
So
me?
look, you can answer this question. Yeah, can you hear me okay?
Yeah, I just asked you something, but like it blacked out, so I understand.
Yeah.
Could
I
I?
didn't hear what you said. Go ahead, ask it again.
Oh, sure. I was just wanting to know. I did say that question out loud. I said, like, should I know the volume of like using integrals, like of a rotated 3D shape, in calculus? Do you think that would be on the test, since you even said that you help like some kids in college like take this test? Is that typically on just a math placement test? Because it doesn't list it, but I figured you know it better than me.
I wouldn't think that would be on there, but I don't know. If they're trying to place you in a calculus class, if they've already determined that you're going to be in a calculus class, maybe to determine if you could take Calc 1 or Calc 2. I don't know. It's a good question.
Okay.
Did you know what the answer for this is? Did you do this right? Can you tell me?
Yeah, I think so. But
All right, so let's find out. If this is 30 degrees, then what? And this is
oh wait,
60.
no.
Then which of 3 is the smallest? Which of these has got to be the smallest?
Well, according to the actual chart, the actual like oh, sorry. I thought that was the thing. Like the numbers would be correct, but I should mixed up 16.
That's right. That's right. These should be, 60 and 30 would be in the other places. That's right. Good. Now it's correct.
Okay. That makes sense then. Thank you. And like,
And then you asked here, does the unit circle you're talking about? Does the
yes,
unit circle?
like for example,
Okay.
like all of the triangles. Like, do they all like connect with the x-axis only?
Yes, they do. That's the reference angle. The reference angle is always the angle with the x-axis, the closest angle with the x-axis. Yep. So that's that one. This is this one. And this one would be this one. Yep. And then these ones would be going this direction.
Okay. Oh, okay. That makes
Got
sense
it?
then.
Yeah.
Yeah. Thank you.
Yep. What else you got here? I don't understand the difference between parabola and hyperbola. So a parabola, well, they didn't draw a hyperbola very good here because that's really not the hyperbola. The hyperbola, it's the cross section of a double cone. So the hyperbola would be like this. And it would have been here as well. It would have been this cross section here as well. So it would look like this. That's a hyperbola. Whereas a parabola, see how this is just cutting one of the cones? The parabola is just this cross section. That's what a conic section is. It's a cross section of cones or a double cone. A cone standing tip, two cones standing tip to tip.
Oh,
so
and
this one isn't gonna touch both cones, right? So it doesn't matter that you didn't draw the cone in for the parabola because it's only gonna touch one of the cones. A circle, it's only gonna cut at one of the cones. An ellipse is only gonna cut one of the cones, right?
but a hyperbola,
in fact, yeah, but a hyperbola would cut two of the cones. If you put it this way, the hyperbola is gonna cross section two of them. So the cross section, if you looked at just the cross section, whoops, sorry, I did that backward. It would be like this. So a hyperbola, here's what a hyperbola is. It's got a center. The center of a hyperbola is not on the hyperbola, but there's a distance here and a distance here. And these two distances have to do with the box. And that box, the diagonals of that box are what form the asymptotes for the hyperbola. So the hyperbola, really, that point is on the hyperbola and that point, and those points are on the box. But the other points don't have anything to do with really that box. They have to do with the asymptotes. Does that make sense? So this distance right here is called, that distance right there is called r sub x. This distance here is called r sub y. Right? So this full distance of this box is 2r sub y's, and this full distance here is 2r sub x's. Right? I don't have to draw that in, but basically the equation of this asymptote has to do with the slope is the rise over the run is r sub y over r sub x. That's the slope of that asymptote. See the rise and the run? And it goes through the center point. So the equation for the asymptote would have to do with this central point right here. If you call that h comma k, it would be, you remember how you do y minus k equals slope, which is r sub y over r sub x, times x minus h. And it would be plus or minus that too, because there's one going up to the right and there's one going down to the right, because there's two asymptotes there. So that's the equation of those asymptotes that form that, or help form that hyperbola. And this point right here on the major axis of the hyperbola, which isn't necessarily the bigger number, but it's just the major axis, and that's determined by which one of the squareds, if the y squared was positive or if the x squared was negative, it would be going one way, and I don't honestly remember, or if the y squared was negative and the x squared was positive, it would be going the other direction. You'll have to look it up. I don't remember which is which, but one of them is going that way and the other one is going this way. I always forget which is which, but I don't even want to guess. But that's what a hyperbola is.
okay,
Versus an ellipse. Whereas an ellipse is just a cross section of one of the cones, the full cone. See, if you do a cross section here, it's not going to go through this other cone. If I draw a double cone up here, if you did a cross section right here, it's not going to go through that other cone. So you don't have to draw the other cone. But for a hyperbola, it is going to go through both of the cones. So you should draw the double cone for the hyperbola. Okay. So that's what a cross section is. It's technically just a cross section of a double cone. Yeah, that's what a conic section is. Okay.
Okay,
All right. Your
thank you.
last question says find the limit of that.
Yeah, it's kind of like I was looking at, it was like a trig identities question because I know like that was
Mhm.
one of the things that like I had trouble with. I don't
So I
know.
think what you could do with sine 2x, isn't the sine 2x the same as 2 sine x cosine x?
Oh
I think it
yeah.
is.
I guess I was like
I
also
think that
sorry,
what
go
I
ahead.
would guess is that you would do that. You would write it like that because then I can cancel the sine x's out. So that really just equals the limit as x goes to 0. The limit as x goes to 0 of 1 over 2 cosine x. And what's the cosine of 0?
Um,
Cosine of 0 is the x coordinate of the unit circle, right? The x coordinate. So the
yeah.
cosine of 0 is 1. Is that right?
Oh yeah. Yeah.
So it's just 1/2. So the limit for that would just be 1/2. That's how I would do it. There might be other ways to do it, but that's how I would have done that one.
Okay. I guess I wanted to know though,
So
like since these are timed tests, like is there anything that like could help this go quicker to like a quick trick to, help me remember like if I know if I'm solving for trig identities or if it's just like algebraic question.
I don't really know. I don't really know. I think these tests like this, like ACT, SAT, they kind of write them in such a way that they don't expect you to get them all right. They just want they're taking you know your answers are more of like almost like a personality test. Like when you're answering personality tests, you know how they just kind of there's lots of questions and they wear on and maybe you don't answer them all right, but the whole overall results that you give them a picture of who you are. That's really what these tests are. So there's not even so much a way to study for them more than just preparing yourself, which you've done very well throughout you know the years of high school, preparing yourself by really understanding things at a deeper level and not just memorizing things for a test. So you're going to do well on this because you're that kind of a person. Like you've
Thank you.
always like really wanted to understand, you know what I mean? You've always wanted to understand it. So I would say don't worry about that. Don't stress about it. Just look at it. They think of it as a challenge, and if you can't find the answer, if it doesn't come to you like the best way to do it, don't spend too much time trying to think about it. Make sure you get through the whole test because it probably doesn't matter that you get them all right. And if you spend 5 minutes on one answer or one question and it makes you not get to the last 5 questions on the test, you probably would have done better just looking at it and going, I'm not sure, I'm just going to take a guess and then moving on. You know what I mean?
Okay. Yeah, that makes
that's
sense.
what i would that's what I would recommend.
Okay, thank you. And I did want to
Any other
ask,
questions?
uh, yeah, but just like general,
Uh-huh.
how would you like I know I asked this on text, but how would you like us to pay you? Like,